Good morning, class. We are looking at chapter 3 derivatives, section 3.5, the chain rule. Here's part 2, implicit differentiation. So we looked at the chain rule, which results from a composite function. As you can see here, we have differentiation formulas you have seen, various differentiation formulas from the definition to differentiation, basic differentiation formulas to the product rule, quotient rule, chain rule, exponential rule. And now 3.5 part 2, implicit differentiation. Functions expressed by one variable are defined explicitly in terms of another variable. Example, y equals x squared minus 2x plus 1, or in general, y equals f of x. Some functions are defined implicitly by a relation between x and y, such as x squared plus y squared equals 25, or x cubed plus y cubed equals 6xy. In some cases, it is possible to solve such an equation for y, and in some cases, it is not easy or even impossible to do so. In such cases, we can use the method of implicit differentiation. This consists of differentiating both sides of the equation with respect to x, and then solving the resulting equation for y prime or dy dx. Bear in mind, this is Leibniz's notation indicating the independent variable is x. That's the advantage of dy dx to y prime. A simple example. We want to differentiate 4x plus 2y equals 10. This is a warm-up example. We want to do it both ways, explicitly and implicitly. Explicitly, we have to solve for y. We are going to move the 4x, make a negative 4x on the other side. Divide both sides by 2. Y becomes negative 2x plus 5, and its derivative is simply negative 2. This is the good old-fashioned explicit format. This can be done implicitly, which means we are going to differentiate 4x and gives us 4. We can differentiate 2y. Remember, g of x acts like a y. The derivative of g of x is g prime of x. So the derivative of y is either y prime or dy dx. So 4x is 4. 2y is 2 dy dx. Any number, including 10, results in 0 when you differentiate. Move the 4. Divide by 2. On purpose, I called it here y prime. I called it here dy dx. As you can see, the answer is the same. But that means the same thing, y prime or dy dx. And whether you do it explicitly or implicitly makes no difference. However, in some cases, we have no choice but to do it implicit. For example, here, given the circle x squared plus y squared equals 25, we want to find y prime. Remember, This is a circle centered at 0, 0, the origin, with the radius being square root of 25 or 5. And so to do so, you have a choice. You can solve for y. This is doable. But we are going to do it implicitly by taking the derivative of each side. X squared is 2x. Y squared. Take a look at this one, the extended power rule, and I'm going to change g of x to y. So the derivative of d dx of y to the power of n, just like this, is n. G of x to the power of n minus 1, that means y to the power of n minus 1. G prime means g y prime. Therefore, this is 2x, this is 2y. Y prime, any number, including 25, results in 0 when you differentiate. You move the 2x. You're solving for y prime. Therefore, you divide by 2y. Y prime becomes negative x over 1. We want to find the equation of a tangent line to the circle at this pair, 3, 4. Tangent line, we need two things. We need a pair x, y, and we need the slope. This is the derivative. This is not the slope. Becomes a slope when you evaluate it. So x is 3, y is 4. Plug it in. And now this becomes the slope. When you plug in, becomes the slope of a tangent line at this pair. Y minus y1 equals m times x minus x of 1. Y minus 4 equals m negative 3/4 x minus 3. You are going to distribute you're going to move the negative 4 to the other side. Becomes positive 4, and as you know, positive 4 is 16 over 4. We end up with y being negative 3/4 x plus 25 over 4 as the equation of a tangent line on the circle of x squared plus y squared equals 25 at the pair 3, I remind you, the pair belongs to the original equation, original relation in this case. It's not a function. And 3 squared plus 4 squared equals 25. Also, it belongs to the tangent line. So if you check it with the tangent line and it works, which we'll do, that means this process was done right, okay? Doesn't say anything about proper differentiation. Find the y dx or y prime when x cubed plus y cubed equals 6xy. We are going to differentiate implicitly, as you can see. Solving for y is near impossible. And so x cubed gives you 3x squared. Y cubed, the extended power rule, the derivative of g of x to the power of n is n, g of x to the power of n minus 1 g prime of x. Therefore, the derivative of y to the power of n is n, y to the power of n minus 1 y prime gives us 3y squared dy dx. Again, whether you use dy dx or y prime makes no difference. Now, the right side is the product of two pieces. So I'm going to put a raised dot in between. And I'm going to call this f times g. And I'm going to use the product. So I need f prime, which is 6 times g, which is y, plus g prime f, the derivative of y is just y prime or dy dx times 6x. And this, everybody, is the one and only calculus step. We are solving for dy dx, which means this which involves dy dx, we are going to move it to the left, becomes negative. This one, which doesn't involve dy dx, we move it to the right, becomes negative. And the next step is factoring. We are interested in dy dx only, so that's all you need to factor. However, there's a common factor of 3. You can take that one also out. So we get 3 times y squared minus 2x times dy dx, and the right side also there's a common factor of 3. Divide both sides by 3 times y squared minus 2x. And dy dx is 2y minus x squared over y squared minus 2x. Find dy dx of y prime, where the relation is 4x squared y plus 2y squared equals 18. Again, notice this is the product of 4x squared and y. Remember, you can keep the 4 out. I've mentioned that before. But 4 is a fairly easy and small number. You can think of it as part of x squared or put brackets here. Keep the 4 out. I'll put a raised dot in between, meaning I'm using the product rule. So this 4x squared gives me 8x times g, which is y. G prime, the derivative of y is y prime or dy dx times f, which is 4x squared. Now move on to 2y squared, and I follow that the derivative of y to the power of n is ny to the power of n minus 1 y prime. That gives us plus 4y y prime, any number including 18. Its derivative is 0. Again, done with calculus. Since we are solving for y prime, we are moving this part and we are factoring the y prime out of this 2, and they happen to have a 4 in common. So this moves, becomes negative 8xy on the right. This one, not only the 4 comes out, the y prime comes out, we get x squared plus y. Divide both sides by 4 times x squared plus y. The left side is left with y prime. These two cancel each other. The numerator becomes negative 2. So negative 2xy over x squared plus y. We are going to differentiate this term by term. B equals 4x squared plus 6y plus y squared equals e. 4x squared, the derivative is 8x. 6y, 6y prime, or 6dy dx. Y squared, 2y prime. E is a number. Any number, its derivative is 0. And so we want to take the y prime out so we can combine these two, move the 8x to the right and make it negative. These two, we can take the y prime out. Number 2 happen to be in common, so we get 2y prime times 3 plus y on the left, and on the right, we get minus 8x. We are going to divide both sides. By 2 times 3 plus y. Number negative 8 and number 2. This goes away. This changes to minus 4. So now the numerator is minus 4x. The result is y prime is minus 4x over 3 plus y. All right, class. We are differentiating this, and we notice that the first one, it's x times e to the power of y. We put a raised dot in between, and we use the product rule. Which means f prime, which is 1 times g, which is e to the power of y, plus g prime f. I want to remind you, when it comes to exponentials, the answer is always itself. Then you look at the base. If the base is not e, you need natural log of the base. Then you look at the exponent. If the exponent is the independent variable, you're done. But if it's a function of independent variable, you need its derivative. So the derivative of e to the power of x is itself. The derivative of e to the power of kx is itself times k by the chain rule. The derivative of e to the power of g of x is itself times g prime by the chain rule. So plus e to the power of y, the answer is itself times y prime or dy dx. That's g prime. Now f, it's x 2y cubed. To take the derivative of 2y cubed, again, I remind you of the extended power rule. The derivative of g of x to the power of n is n, g of x to the power of n minus 1 g prime. So d dx of y to the power of n is n, y to the power of n minus 1 y prime. So this becomes 2 times 3y squared y prime, meaning 6 y squared y prime, and 3x is, of course, 3, done with calculus. These two involve y prime. We are going to put them together and factor. whatever we can, and we're going to move this to the other side. When we move to the other side, this becomes negative. Over here, when we factor the y prime out, we get x e to the power of y from this piece and 6y squared from the last one. As I mentioned, this goes to the other side, becomes negative. All we have to do, divide both sides by the parentheses, and that gives us y prime. Find an equation of a tangent line to x squared y squared equals 1 at negative 1, 1. When you want to come up with the equation of a tangent, you always need a pair, x comma y. It's given. And again, they don't have to give you x comma y. They have to give you x. You can figure out the y. You also need the slope. To come up with the slope, you need to differentiate. Therefore, we are going to differentiate this implicitly. We notice it's the product of x squared and y squared. We put a raised dot in between. We make it into a product rule. F times g. So the answer is f prime g plus g prime f. So f prime is 2x times g, which is y squared, plus g prime. By now, we should be very comfortable with this. 2y prime times f, which is x squared, and any number results in 0 when you differentiate. This is the only calculus step, everybody. So this is fg. So this is f prime g. This is g prime f. And so since you're solving for y prime, you are going to move this to the right, make it negative. You are going to divide everything sitting next to y prime by, so you're going to divide by 2yx squared both sides. So the left side is left with y prime. And the right side, almost everything cancels out except minus y over x. So that's y prime. Again, this is not the slope. This is the derivative function. Becomes a slope when you plug in. In this case, you are going to plug in the pair negative 1 comma 1. The notation is m equals minus y over x evaluated at the given pair. So you replace the x with negative 1, y with positive 1. Both of them become negative. The ratio is positive 1. Y minus y1 equals m times x minus x of 1. So y minus 1 equals m, which is 1 times x minus x of 1. X minus minus 1 makes it x plus 1. And so we have x plus 1. We move the negative 1, make it plus 1 again. Y equals x plus 2. And notice if you plug in x, you do get y, meaning this pair not only belongs to the original relation, it also belongs to the tangent line. And when you check, it means this process was done correct, has got nothing to do with finding the slope.